Thanks, everybody. Thanks for the invitation to talk here. My name is Frank Slyne from Trinity College in Dublin, and I'm presenting on integrating OpenIreland and COSMOS testbeds for delivering a cross-Atlantic open network solution. So this is very much a joint project between Trinity College and the COSMOS group of universities in, or COSMOS. The universities involved in the COSMOS testbeds in the New York area. So I see that Ivan's online. So he's framed. We work quite a lot with Ivan Sasker on this initiative. So in Trinity College, we have received funding for a testbed called OpenIreland, and this is an inside and an outside testbed that spans the college campus in Dublin. So in the center of the screen there, you see a sort of a heat wave map whereby we've deployed ORAN 7.2 Benetel ORU devices, and we have a sort of that the funding for OpenIreland funds several thousand kilometers of fiber and almost like a full stack of computer equipment, from servers to optical EDFA and ROADMs, etc. Devices for open disaggregated networking such as Cassini and Phoenix, disaggregated ROADMs for virtualized PON, and as well as conducting experimentation on open source 5G such as OAI. One of the spin-off companies from Trinity College that we leverage as part of our research is SRS. So they're quite a well-known entity in the whole LTE and 5G open disaggregated stacks, etc. So the thing really is that on the lower right-hand side, we have basically an abstract then of the topology, and central to this topology in OpenIreland that we leverage as part of this project is a very large optical space switch, and that allows us to actually, it creates a low latency optical patch panel, but it's very much dynamically configurable, and it allows us then to create many different topologies such as tree structures, rings, etc. And from there on, then patch in virtualized servers and all the ROADM and Wi-Fi equipment, etc. So the OpenIreland project has got funding from Ireland's Science Foundation Ireland, which is the government agency for funding research. And as part of that, we've been able to get from the regulator 100 megahertz of spectrum licensing, and that's available for researchers who are is there? Yeah, it's all right. All right. Okay. So so the OpenIreland testbed is available for researchers to test both optical and radio experiments, but also aggregated and convergence architectures where the paradigm of OSI and TCP, etc., are actually broken down. So in OpenIreland, we invite researchers, both funded as well as industry, and therein contribute to the actual sort of the experimentation in the testbed. So the 100 megahertz is within the 3.8 gigahertz N77 band. So
Just click on the screen.
Yes. So I come then to the actual experimentation that we did with COSMOS then. So I've given a little background on Open Ireland. And as I mentioned previously, COSMOS is a group of, well, it's a, I suppose you call it, is it a PAWR? It basically is funding from NSF in the States for a group of universities to build an open testbed around New York. And so this has been in place for the last 5 or so years. And our professor, Dan Kilper, is a professor also, or an associate professor in Arizona, which is a participant in the COSMOS testbed. And just like in Open Ireland, we've got a very large space which for creating dynamic topologies involving low latency. Similarly, they have similar architecture that allows experimentators to do similarly in the States. So the crux of the experiments that we conducted then as part of NGIatlantic is the ability for us to link up the testbeds using a transatlantic network, and also to perform the equivalence of experiments then in COSMOS and also in Open Ireland. And I mean, the challenges there in terms of conducting equivalent experiments is that architectures are different. You know, the actual technologies are different. We use a Pilatus space switch. The COSMOS testbed uses a Callian switch. We, in our radio platforms, in terms of the nodes, we use a lot of National Instruments, ETIS, USRPs, and they do sort of similar. So the thing is, the experiments that we're conducting then is to allow researchers to provide open access and create topologies, and then conduct experimentations between them. And the final thing I say about the Open Ireland testbed is that we have strong relationships with the rare P4 testbed that spans the GIANT network in Europe, and also we've done a lot of sort of research with the RNP and UFIS in South America and Brazil. So we come then to I suppose the experiments then that we conducted as part of the NGIatlantic project. So the first one involves a quality of transmission estimation experiment. And this really is creating a machine learning algorithm that allowed the placement of slots in the fiber optic spectrum. So you might be familiar with FlexGrid and fixed grid, but basically, if you control the network and you have a vendor supplied network, then you set up your network and it's good to go. But the problem is that unlike a radio network, that when you turn on and off lasers or modify the power of your EDFA amplifiers, that can affect your neighboring channels. And so if you have a spectrum of 95, 50 gigahertz slots, then the proximity and the power of the neighbors will affect the performance of the slot that you're using or the group of slots. So what you have to do is you have to allocate and position your neighboring channels wisely. And the question is, how do you do that? And what we did here was, as part of this project, is we created a training regime where we had a channel under inspection, and then we added channels, neighboring channels in I suppose, a random but incrementally more complex manner. And you train your reinforcement learning algorithm then to to basically answer the question, where should the next neighboring channel be placed in your spectrum? And this work was done within the project in conjunction with Politecnico di Milano, and the results were actually quite successful in terms of in a matter of seconds, as opposed to the days or months that a vendor would actually take to create this from scratch. Having trained the algorithm, we were able to within so the full training of the reinforcement algorithm took sort of the best part of a week, but then to actually allocate the slot was basically a fraction of a minute. So you can see there on this diagram is the architecture that we created and the reward functions. So this was actually quite successful. The second experiment then involved the I suppose the interworking between the various test beds. So on the left-hand side here is quite blurred, but basically what we have here is all the various components there to create a 10 gigabit E-line circuit from the test bed, the OpenIreland test bed in TCD, through the HEAnet NREN, all the way up to GIANT, across to equivalent of GIANT in the United States, and down through Canada, then into Rutgers, and then into the COSMOS testbed. So basically, that is a circuit. To actually build this, it's like building a barn in terms of there is probably 8 or 9 different technical entities that need to create this, and each of those elements then has to be manually provisioned. Some are provisioned over fiber. In the old days, some of those links might be microwave, and other things could be E-line or Ethernet circuits, etc. So that was one of the deliverables. But the purpose of this experiment then was to create an SDN provisioning circuit that allowed a radio transmission to be generated on the COSMOS testbed and then transmitted across this link to the OpenIreland testbed. And basically we had 2 or 3 different flows, and the challenge really was, given a limited capacity on an overall circuit, to be able to modify the bandwidth allocated to one flow at the expense of another one, and thereby implement a rudimentary type of quality of experience or quality of service regime. And you can see here that in terms of the graph on the right-hand side, that as one bandwidth increases, like from 20 megahertz to 40 megahertz, then the bandwidth on another circuit actually decreases. And this is all done in real time. So how we implemented this is we implemented a number of VLANs across this self-same circuit. So we were using VLAN within VLAN tagging. And so basically what this simulated then was the ability to create a wide area and a local area and a local access type of dynamic configuration that was run independently then of the underlying E-line circuit. And this then, as part of the experiment, then we created a number of user interfaces then that allow experimenters to conduct the same experiments then on the OpenIreland testbed. So this was so on the left hand side, you can see here that we can create topologies. So we can create ring, star, and tree structures. We can record the topologies and then deploy them through the Plata switch and create virtual machines and virtual networks. And then there's another tab then that allows you then to do a trace of the optical spectrum analyzer, and that's all accessible through the through the web. So in closing, then, so we got some very good sort of results that demonstrated both interworking, but also the equivalence then of conducting experiments between the OpenIreland and the COSMOS testbeds. And it demonstrated a successful cooperation then between TCD, Rutgers, the other COSMOS participants, as well as Politecnico di Milano. And the PIs involved in this were Marco Ruffini from TCD, Dan Kilper, who's TCD and Arizona, and Ivan Saskar as part of the Rutgers COSMOS team. So thank you very much for your time, and if there's any questions.
Thank you very much, Frank, for the very good presentation. Your project was actually a perfect example of our category on experimental platform interconnection. So, you know, having mature platforms on either side of the Atlantic to, you know, use, you know, the grants to interconnect. And one of the caveats that we always had with this particular one was that it would be very useful if those interconnections could be used for the future, you know, NGI experiments. So, you know, hopefully in the calls that Jorge mentioned this morning or earlier in the session, you know, there might be some opportunities for those kinds of interconnections. Okay, so maybe just keep that in mind. Okay.
Yeah, so the that connection is still in place, and the work with COSMOS is still ongoing, and even to the extent then that there's a number of experiments then that are starting to address the question of running, you know, protocols, particularly TCP protocols over long links. And as anybody who's actually used TCP, you know, it's actually subject to the law of like where you have to guarantee a sort of you have to fill the bandwidth, but also guarantee a sort of that the packet loss can't drop, etc. If this was if you're running sort of the entire network, like a Google or an Amazon, etc., you might do things a different way. Like you could just implement a sort of a means of mirroring data between your data centers using UDP or something like this. But the challenge here is we've got open systems and open networks, and the best open protocol for doing something like this is TCP. So just close off the point. Yes, the analysis and the test beds are still being used, and they're being used productively for research currently. Yes.
Okay. Thank you, Frank.
Any other questions? Go ahead.
In my case, well, I have a similar question to Jim, and it has been already answered by you. So it was related to the fact that in this moment, Faith for Fire, I understand, is over already. Now the activities that NGIatlantic did also to support this interconnection are over. So I wanted to understand that how are the things happening in this moment. So, but from your answer, I understand that you're still keeping alive the connections, no?
That's correct, yes. And and I suppose within the radio testbed, we've had a long relationship with the Fed for Fire project, participating in the football project and Wishful and other things, other initiatives. And we are keeping a very close eye then on I suppose the Slices RI initiative, which is, I suppose it's the larger sort of groups of open test beds that are being sort of discussed as part of the European Union. So I think NGI will have a very important role to play in the sort of the connectivity between those test beds across the Atlantic.
Thank you very much.